Welcome, this is where nerds come to learn things. If it's your first time here, click on the subscribe button and on the bell icon to get notifications about new videos. Thanks for watching, hope you enjoy it. Alright, so here's the Agilent power supply, which I showed previously in another video and also did live streams on trying to repair it. And the issue with this is that I need to finish the repair. And I just need to replace that reset IC, this is down there. I need to replace that because it doesn't work. So I've got these parts here, which are the supervisor ICs. These are MCP100-475HI/TO TO92 package ICs. And it's just like I'm going to bodge those in there on a little circuit board, which I'm going to make, and I'll do all that right now. But first things first, to get the original part out, and that's going to be a bit interesting. Yep, well, that worked. It fell out. It's in there somewhere. There it is. Okay. There's the beastie. CS8122. Okay, so now I need to make that little circuit to replace that. Now I've already got an idea. I've actually got a couple of options there. Now I could build it really simply with just a Zener diode to step it down and then the IC, or I could put in a voltage regulator and then use that to power the IC, which is probably the more robust way of doing it. I'm kind of undecided about that actually, I should really think about that. So I've got some board here. So I don't need a lot of room. Let's see. It needs to be quite small to fit into the space too. So if I have a row for the connections to the PCB, a row for the part, a row for the Zener. So I'll do 4 rows, that should be enough. Let's get one more row. Alright, actually I don't need that like big, do I? Let's get that big. There's that part. Now I need to give us a scrape. They always seem to get a bit of tarnishing on them, so I just like to freshen those up a little bit because they always end up being a bit of a problem whilst trying to get them solder. I find it helps a lot on variable. So I'm probably going to use header pins with maybe header socket on the main board. That's something I consider actually, is the pin spacing. I should think about that. Pin spacing is not the same as on the board. It's not the same pitch. So, although it's really close, I might be able to get away with header pins and just bend them very slightly. I probably can do that. Let me have a look. So these are quite long ones, so it probably doesn't matter. I can actually just bend them a little bit and make them fit in the holes and line them up that way. That way it doesn't actually matter. I'll just stand off slightly. It should be fine, I reckon. So yeah, the spacing is definitely slightly different, so I can just use those and I'll just cut off the length I need once I've got the things in there. I reckon that's the way to go. Got it. Let's get that bit soldered on. Right. So I need the part here. Get my eyes out. Now to think about orientations. Because I'm kind of doing it in reverse, I'm going to be doing it upside down like this basically. So at least I've got that orientation there correct. Also the PCB's upside down, but yeah, whatever. Now I need a 12 volt Zener, which I already have in here. So all I've got to do is go between the voltage in and the VDD pin of the device in that orientation. Oh, missed the hole. I think this is 1 Volt Zener or something. It's quite a chunky one, way more than it needs. So I did get the right part. I was hoping it'd be here by now, so I could actually just drop that part in and see how it goes, and then do this if it didn't work. But it's not here, so we shall carry on. Okay. In theory, this will work. 1 UF. What's that rating? 50 volt. Yeah, that's absolutely plenty. So I want that across the VDD and the ground, which would be those two there. So I'm shoving the bottom of the board. Because, you know, why not? Having a little capacitor on there should mean it gives it a slight charge up time. Wouldn't be much, which might help smooth the rail out a little bit when it first turns on. Well, in theory, that will do the job. Well, guess we'll find out though. I should probably do a test outside of the unit before I put it into the unit, just to be sure it's actually not going to have a problem. Just in case I've got something completely wrong or screwed something up. Rather find out before I put it in. Let's get some leads. Right, let's get this thing installed in here. I completely forgot to record the oscilloscope testing, which was a bit silly on me. I should have recorded that. Never mind. A little sanity check, make sure I got it right. Yeah, I think so. Approach moment of truth. It's not the prettiest bloody solution. I mean, if the once those other parts arrive, I'll actually try putting those in and see if they work. If they do, then it'll stay in. This is kind of a temporary thing just to see if it can do it. Right, let's power the thing up and see if it works. If it goes bang, so I made some kind of mistake. Right, power that on. Power this on. Well, let's see what happens. Oh, that doesn't look right. No, see this? Nah, see that? It's flicking around. It's nah, that's not right. That one's not working. Maybe that 5 volt threshold isn't suitable. Maybe it's still pulling it down, effectively being 5 volts. Then I think there's a diode in series, so it shouldn't actually matter. Let's do some more testing, see what happens. Let's see, yeah, I'll have to use the scope again, let's turn it back on. And I need the ground reference, which is going to be different to before. Which reference was that one using? I think that was using the channel 2 negative as a reference for that. I can find out in a second. Well, that's interesting. That supply isn't very smooth. Let me change my camera view so I can see it as well. Maybe that's what's going on. Maybe the supply is so ripply that it's not actually working properly. Maybe that's what the main issue is with that thing. Let's see what happens if I probe on the... Which one was which? Again, I've forgotten. Ground. Reset is the end pin. That's the reset there. So it looks like it's trying to go. That's a lot of noise. What are we getting there? About 2 volt peak to peak. I'm pretty sure it's not meant to be there. 50 Hertz coming through. Does that mean I actually missed something on the power supplies when I did my initial testing? It's entirely possible. I checked all that too. What did I miss? Capacitor's over here. Aha, look at that one there. That cap right there. And that one. These have been replaced previously. I can see they've been resoldered. So it looks like there's a problem back here. Let's check this side. It's got a bit of rip on that one. Yeah, it's bad there too. Very interesting. I might have to step back a bit here. Maybe I'm chasing the wrong thing after all. Right, so I put that new part in and it's not working, which is what I'd expect it to do. I'd expect it to work. And I thought I'd probe the supplies and there we go, got this big ripple on there, which is obviously set to AC coupling right now so I can see the ripple only without the DC offset. But that's what's actually going into it. So maybe the problem with that original part wasn't actually that the part was bad, it's that the supply was bad and I missed it before. So probing around these other caps which are over here, just C504, get that big ripple on that one as well, because these caps have been resoldered in the past by someone. So it looked like they've been replaced already, so I didn't really worry about it. I mean, it's only 10 years old this thing, so it shouldn't really be that big of an issue. But there's ripple on those caps there. I don't think it's just common mode noise, I'm pretty sure it's not. And a ripple on those caps as well. So I'm wondering if I need to replace these caps again. Whether it's coming from somewhere else in the supply and that's just those caps trying to deal with it. These output caps don't seem to be doing much. There's a little bit on that one. A little bit on that one. So I need to look at this and just go back to the diagrams and check our supplies out because I think I've missed something. Right, so after looking at the diagram, C130 and C140 are suspect caps causing ripple on that line, and they're just there underneath the heatsink, underneath the transformer there, the metal frame of the transformer. So they're easy to get to. So I shall pop those out and replace them. I'm sure I've got something I can replace them with. Polarities, negative towards the centre. I've never got dots on the circuit board anyway to show negative. values or on the circuit diagram, but the circuit diagrams had lots of issues with values and stuff being wrong, so I don't trust those. I might have to wait until I pull the things out. So let's do exactly that. Let's pop these things out. I'll do them one at a time, so I'll make sure I get the right one in the right place. Untangle the wires. Slightly better. Right. Now I've lost them. C130 and C140. Here we go. These ones have not been replaced. They're still original solder. That's not going to come out easy. Okay, C130 out. Let's see what we got. So we've got a 1000 UF 50 volt. Obviously the main contact's on the other side of the board and it's pretty thick. There we go, got it. Right. Should really finish my coffee. I don't like to use these because it's a bit rarer, a bit harder to get, but there's a Vichy 1000 UF 40 volt. That did a job. Looks like it's got thinner leads. So if I stand on an end, I reckon it'll work. Here we go. Right. So it's not a perfect solution, but yeah, it'll do the job. You'll probably have to tip this thing over on its back actually, otherwise it's going to not flow through to the other side of the board like it needs to. Bit of a shame they made the component lead hole so bloody small. If they had slightly more clearance in there, would have been alright. Trying to get the heat right through to the other side so it will flow. I don't know if it's done it or not. Well, let's try it again. Let's see what happens. See if it's any different. And you can't see the display, can you? Of course not. Still playing up there. It's not a good sign. And the ripple's still there. So that's very interesting. It was noticed from the live chat, Ian noticed it I think, that the parts numbers for the C130 and C140, they've got the same HP part number but different values. So it's possible it actually has the wrong value cap in there because the ripple was really bad across it, even after replacing it with a new one. So it's entirely likely that the cap is the wrong one. So we're going to look at, I'll get this plate back away again. So I'm going to look at replacing that cap with a larger value and see what can physically fit in the space, and we'll go from there. So let's take that one back out again. I'll have to do a little wiggle. Yeah, I'll have to wiggle the thing out. Oh. Well, wires will take that one. Of course they are. Problem is all the main connections on the top of the board, so it's sucking all the heat out. stick it out. There we go, that's one. Come on, let's go. Gotcha. Right. That's a stubborn bastard, I'll tell you. Right, so I've got here somewhere. Where are they? There they are. Right, time to use these. These are for desoldering parts. I'm yet to use them, but it might be suitable for this. Here we go, I got it out. Got that slug out the hole, that's good. Sweet, I knew it would come in handy one day. That's what I got them for. Just check the chat out. Well, it's going to go with this one, 2200 UF, 35 volt. I'm going to try and squeeze that in there. And hopefully I'll get the leads through the holes. They seem to be a bit close to the hole size, so I might be able to get them through the holes. But we'll see how we go. They may or may not fit. Oh, nice, going through. Cool. Excellent. I'm even putting it right around. That's always a good thing. Now, it just goes in there. Right. I'm trying to get a side view for this. So there's the cap that's there. Again, we'll try and get the heat through the board so I can actually solder on the top side. Trying to see if I can actually see into the top side there. Maybe I can solder directly on the top side. Get my iron in the gap. I'm not sure it's flowed through. It needs to. No, it's flowed through a little bit. Just a little bit. Okay, well, let's cut those legs off and give it another check and see what happens. $280 millivolts. Well, it's certainly a lot better than it was. Yeah, let's go back to DC coupling. But it's still not turning on that reset line. Or rather turning off the reset line. So that part doesn't seem to be sufficient, which is a shame. So what I'm wondering now is if I get the original part here and maybe hook it up to a test rig and see if I make it work outside the unit. Maybe this part's okay. Maybe it is. Maybe I should try putting that back in again. What do you reckon? Just in case it is alright. Alright, let's take this supervisor IC back out again and we'll try putting the original part back in now. I've smoothed out that main rail there a little bit. See if it works now, you never know. This is one of the reasons I don't like to destroy components unless I'm absolutely sure they've failed. You know, if I can get them out without destroying them, I try and avoid that. Because you never quite know. You know, you may think you've got a conclusion, actually you might be wrong. That might be the situation here. We'll find out soon. If not, I'm going to have to wait for the other part to turn up, then I'll replace it again. The LM2925, because I was hoping it would be here for today, but unfortunately it's not arrived in time. It would be annoying if I did all that and it turns out it's just a bloody power supply rail. I think I'm going to have to check all the rails and just be sure that they're all okay, because I'm suspicious of those now, for obvious reasons. Hey, look at that, it's working now. Calibration's out, but it's working. Let's make sure it's not a fluke, do it again. And I'll check that rail again as well in a second, the scope. So channel 1 works fine. Channel 2, oh no, it's 0.37 again, didn't work that time. Maybe not then. Or it's still too noisy. Okay. It worked once, that was interesting, isn't it? It's the one I had before. So let's just check these other rails out, shall we? Yeah, let's do that. Okay, so there's more than one issue there with the rails. That seems to just be tied to that one anyway. So that's right on the leg of the device. Yeah, still quite a big ripple there. Still only 280 millivolts, so it's a lot better than it was. It's, you know, a fifth of what it was, wasn't it? It was about a volt before. So let's just check over here on the actual caps. Yeah, so it's about 260 millivolts here on that cap. Bear in mind, I've got to be mindful of the ground references I'm using. These are the other ones. There's more caps over here somewhere. I've just got to find them. Is that it? 156. I'll have to go and look at the diagrams to figure out which caps it is. It's here somewhere. Oh, look at that. That looks interesting, doesn't it? That is 22 volts AC. I don't know if I'm probably in the right place though. Shut it down so I don't touch it, I'm not supposed to. There's 154, there's 158. They've got these other little caps directly across them as well. C317 and C318 directly across them, ceramic caps. Okay, well, let's just check those. I'm tied to that negative rail there. I think that's the right one. I should be the positive I'm tied to. There's something weird about the side. I think it's the positive I have to be tied to. No, it's a little bit different. Anyway, we'll check. Nothing near. Almost nothing near. 240 millivolts. 480 millivolts on that one. Let's just try go onto this one, just in case. I'm pretty sure it was tied to the positive reference though. Yeah, it's pretty much the same. So that C158 is also looking a little bit too noisy for my liking. So why was that? Where was that really high noise ripple there? That was over here somewhere. There. I need to look at this. That goes to pin 1 of that block. It may be the main AC input. Let's just go to DC coupling, see if it offsets. It doesn't, so it might be the main AC input, so it might be fine. Might be nothing wrong with that. No DC offset. Okay, well, yeah, something's still not right though. I think this ripple's still. I mean, because it's only halfway rectified, that's the problem. It's going to be noisier straight away because of that. It's better than the other channel now. So I can still use a reference there too, that works interestingly. Yeah, I don't know. That other channel over here is isolated from this one. It shouldn't affect this part. So I don't think that's really the problem there. Okay. So let's strap a capacitor across those input pins and see if that does anything. What size should I use? We've got the original 1000. Chuck that in there. If it's any good, I don't know. Oh, here's one of mine. Oh, it's this big one here. We'll chuck that directly across the supply. And we'll see if that changes anything. See if it helps it. Right. Nah, still dead. Okay, let's just look at the rail. So that's with the big cap in there. Yeah, that's a bit more like, isn't it? 9 millivolts. Yeah, and that's before the Zener. So yeah, that's definitely given a clean supply to that IC now, but the IC still isn't resetting. It's still tied low. Yeah, still tied low. So it's not a supply, so the IC is definitely bad. IC is definitely bad. So at least I've eliminated that. So yeah, I have to wait for those LM2925s to turn up then and drop those and see if that solves the problem. But at least we did find another problem at the same time, which is always a good thing. So yeah, don't trust the diagrams. I mean, obviously this part is under spec, but it didn't look like it had been resoldered. Like these other parts over here, they also look like they've never been touched. Although that C158 did a bit of noise on it. But yeah. Right, so this is the circuit diagram for the power supply. So I'm going to show you the bits I was actually looking at. This is the channel 2 section. And these are the MOSFETs here and there. Zoom a bit there. And just here, get it closer. Oh, just jumped. Come back. There, here we go. So this CS8122 here, that's the reset IC. Okay, now this is what's wrong with this power supply. It's U139. I've already done testing all around here, verified that these diodes are correct, they're working alright. These op amps are working correctly. They've got positive voltage this side because it's feeding through these. These op amps aren't pulling the rails down when there's no output. This works okay. I've verified all these resistors, everything. What I found is that CR107 is being pulled down on this side, which can only be from this IC, which wasn't resetting. I found a few problems on the way. I replaced C184, even though it seemed okay. I replaced it anyway because it's possible there's a problem. I've tried loading it down with a different resistor on this side and adding a capacitor on this side as well, so actually change the loading, see if that would make this be more stable. It didn't change anything, and so that IC's definitely got some kind of fault. Now what I did discover when I was probing it with a scope is that there's a lot of ripple on the power supply, and that comes from this VOS. So the VOS comes through, it's got a Zener diode here which drops the voltage. It's about 27 volts coming in, drops it down to about 15 volts or so here, goes to the input of this regulator. Its output, when that comes to 5 volts, it's got an internal reset circuit. When its output has reached a threshold and it's stable, the reset line then goes open circuit, which then means this pull up resistor here can pull the power through and turn on that MOSFET, right? Nice and simple. And then these op amps on the side here, they pull this down through their diodes, so they control the gate by pulling it downwards, right? But what I found is this VOS had a lot of ripple in it. It was doing like a volt ripple peak to peak, which is excessive. So if I scroll down to where that part is in the circuit diagram, VOS is right here. That's the output. Okay, so there's VOS there. That's what goes to that IC. So right here there's lots of ripple. Now you can see this is only halfway rectified, so straight away it's going to be noisier than normal. Right? It's going to be hard to get that noise out when it's only half wave. So you can understand that. Now, what's pointed out to me during the live stream, someone else noticed this before I did, was that these two parts have the same part number, 01802980. Both got the same, but they've got different values, which is odd. And then if you look at some other parts of the circuit, like the companion part over here somewhere, where's that one over here? There's also 1000 UF, same part number. So which part number's right? Don't know. But all the rails had ripple on. This was the worst. And if I zoom out a slice, it's easier. And one of these other rails, I can't remember which one it was now. I think it was 127. Also had a lot of ripple on it, but this is full wave rectified. Maybe it wasn't that one, maybe it was this one. Can't remember. There was still some ripple on these ones too, but these caps haven't been changed. A lot of the other ones have been, so I think these caps also need replacing. But this one here was by far the worst because it's only halfway rectified. So I replaced that cap with another 1000 UF. Didn't help. So then I upgraded it to a larger value. I've now got a 2200 UF in there, and that's made the ripple much smaller. It's only about 250 millivolts now. And because that supply is going to that IC, the ripple was appearing on the IC and appearing on the reset line. Now, that ripple wasn't passing through this voltage regulator. This voltage regulator was actually smoothing all that out just fine. Coming out of here was absolutely fine. And this also had some ripple on it, but not as bad as this rail. And the output from that one is also okay. So, so I've upgraded that resistor, that capacitor to a 2200 UF, and that will be better. It's smoothed it out. Right, so I realised that I did some more testing on that little supervisor IC board that I made and put in here, which didn't seem to work for some reason, even though it works outside of the board, or outside of the unit. I figured, okay, something must be wrong with that board, so I must have made a mistake on it. So I've found two mistakes I'd made. The first is that when I put a capacitor on the board to try and smooth the input a little bit, I put it across the reset and the VDD pin of the IC, not the ground and VDD pin, so it could have been affecting it that way as well. But I took that off, didn't fix it. Then I did some voltage measurements and I realised that the Zener I'd put in, which is 12 volt Zener, which is this one here, although in theory it should have been the right one, the voltage was too low on the IC. Because when I did the original testing on this thing, I was getting sort of 17 volts on the supply to that unit. So I thought if I stick a 12 volt Zener in there, then I would get about 5 volts. Right, so it should have been okay. But it turns out it's actually sitting about 4 volts on the IC. Now the IC itself has got a reset threshold of between 4.5 to 4.75 volts. That's the minimum maximum range it's got, right? So it had to be at least about 4.75 volts in order for the reset to turn off. And because it's only sitting at 4 volts, it was never getting there. So the reset IC, or the supervisor IC, was doing exactly what it's meant to do, which is to not allow the reset line to come high until it's got a decent voltage. It was doing exactly right. So what I have to do is go and change the Zener diode here to a 10 volt Zener, which has increased the voltage by 2 volts. It's now seeing at 6 volts on the VDD of that IC. And now it's working. So that's all good. It actually powers up properly, I'll show you. Stand a bit more so you can see a bit better. So output off, turn the output on, that's channel 1. There's channel 2, it needs calibration, that's why it's sitting a bit low. But it now actually powers up. Okay, so once I calibrate this voltage on here, then that should be a lot better. I just had to figure out how to do that. But channel 1's perfect. Alright, so I should be able to do exactly the same as that. Alright, so no problem. I just need to fix this calibration and it'll be working. So the supervisor IT does work. I am still intending to replace the IC with a drop-in replacement part, which I'm waiting to arrive. So once it turns up, then I can look at doing that. So at least I figured out why the supervisor IC didn't work when I first put it in, when I expected it to work. So now I corrected that voltage on the VDD pin, it works fine. So that's brilliant. You could say that's fixed already, couldn't you? You could sort of leave it at that and say, right, it's done. It's got a part in there. Yeah. As you can see now, I've got a rubber bumper on it. It's actually turned up in a mail bag not too long ago. So it just finishes it off quite nicely and makes it look a bit nicer. Okay, so you can see that part I've put in just there, that little breadboard right on the side, in the corner. That's what I made in order to basically do a temporary bodge, right? That works. It's more of a concept really, just testing the concept rather than just put a supervisor IC in and actually have it do the job. And the answer is yes, it does work. So now I've actually got a substitute part arrive. Well, this is an LM2925T. Now I purchased a bunch of these off AliExpress from different suppliers, or supposedly different suppliers. 2 lots arrived at the same time with exactly the same packaging with the same name on it, as in the same sender. So no, not a different supplier, same person, different name, different shop. Anyway, all these parts are sold as new parts. Well, they're not new, these are old parts which have been pulled out of something. I bent these legs, all the legs were straight, and they obviously had been bent previously and I straightened them out. Some look quite nice, they've been cleaned up, but sort of bag of them here. Some of the legs were actually been cleaned. Looks like they've actually tried to clean them up a little bit to make them shiny and make them look nicer. But the body of some is one here you go, this one here is, you can see it, but it's all corroded on the back. Alright, it's like, look, it's still got heat sink compound on it. It's like, you know, not new. Okay, so but I've tested them all just now. I did a little video on it, which you'll see in future. Maybe it'll be a Wednesday video. And I tested each one of these parts. They all work. Every single one of them works fine. So, you know, that's not a problem. The problem is that they sold them as new when actually they're not new. But anyway, so this is the substitute part. The original part is a CS8122, and those are obsolete parts. You can't get them anymore. I even tried places like ET Source and what have you, and they just don't have them. I asked them and they didn't have anything. No stock. None of us didn't have them. But these are a substitute, which is got suggested to me by someone, I think it might have been Kim, on a live stream when I was doing this repair. suggested to me as a substitute part, and it turns out yes, it's basically pin for pin identical with the same function. So LM2925T, but these are also obsolete parts. But there's some available on AliExpress, at least there were at the time when I got these. So I've got a whole bunch of these now. I like to buy lots because if one doesn't work, I'll blow it up or something, or do something wrong, I've got another one. Or something wrong with this which then blows it up, I've got another one, or another 10, right? I like to build up stock, so if this ever goes again, I'm just going to get another one off my packing and off my storage package and drop another one in. Alright, it's not such a big deal. If I need one, I'll get 10. It's just the way I work. Equally, I may never use another one ever again. So if you get really stuck and you've got one of these power supplies, you need this part, let me know, I might be willing to sell you one. Take that board out, I've got to get this out first, and it makes you wonder, where's the other screw? I've only got one screw holding this board in. I wonder what I did with the other one. I know there it is. I put my parts on the shelf up here when I'm working on things. But I'll lift this board out so I can get in there. We'll desolder that board, drop the part in, and test it, and hopefully that'll be all done. Oh, let's lift this board out. So this board, in case you don't actually realise, it's not just a GPIB board. This is actually the controller. So this is GPIB section over here, and this is all the controller. So this is actually the brains of the power supply is all in here. So it's got some discrete regulators and stuff in here to run the board and reverse circuitry and comparators, and it's all on this board here. So this is all the, the actual power section down here, and this is the controller. So just be mindful of that. It's not just the GPIB board. In case you didn't realise. Right, so there it's sitting there. Right there. Okay, so that's what we're going to take out. Soldering iron is warmed up. Now I need to get my desoldering iron warmed up, and then I can try and get that part out. You won't be able to see exactly what I'm doing when I do this. Okay, so right there, so I'm trying to desolder. Now I've got a little, won't be see it on camera, I've got a little bridge wire here. That's between the supply and what was the output smoothing and loading of the original regulator. I did that to try and stabilise the IC a little bit, give it some more power supply smoothing and cleaning. Because actually quite a lot of ripple on the supplies. What it's got a massive amount of headroom on the supply rails, but it's got a lot of ripple in it. But the ripple doesn't come through the actual main rails because of the amount of headroom. The ripple level was much higher than the actual output voltage. So it doesn't show up on the supplies, it's way above it. But I still wasn't completely happy about how much ripple there was, so I did actually upgraded a couple of capacitors in here to make them bigger, to reduce the amount of ripple coming through. It didn't seem to change anything, but I thought it was nicer. So let's just start with this. Let's get this wire link off first. I should desolder it all. Now, because I've been soldering in and out a few times on these pads, one's a little bit worse for wear, so it's not the best. The pad's slightly damaged where I've been in and out, in and out, in and out with different parts trying to fix it and figure out what's going on. But, okay, just fell out, so it's definitely out. So there's a little board that I made just here. So it's 3 legs all it needed: power, ground, or voltage in, ground, and reset out, because that's all it actually uses. It doesn't actually use the voltage regulator section of the unit. And this part was a, if I can read it, tell me what it was now, HCP 100 was it? Something like that. Will it focus? No, I can't do it. Almost there. Can you read that? Go and look at the live stream because it's all covered in there. So let's get the substitute part. So this is the substitute, and this one here is the original part sitting here. CS8122 is the original part, which is blown. It's got the voltage regulator section, but the reset line is blown on it. So now I've got to drop this in here. Let's move over. And just tweezers to get this in here. Look at that, I've got the legs lined up just right, excellent. Which is why I had the original part sitting there, because I was using it as a guide to bend the legs. Okay. Don't fall out. I think once I get one leg soldered on, then I'll tip it over. I'll do that. Yep, I'll put the other solder. Actually, I need flux on this too, because these used parts, they need to be fluxed. and it's already wanting to fall out. Get back in. Sorry about the friction off the side. I can't do much about that until I tip it over. Hold on. Just need to get one leg soldered on. Then I can change what I'm doing. Right. Can I get that over further? Yeah, slightly. There you go. That's the best I can do, I'm afraid, otherwise it's going to tip over. Alright. So yeah, definitely the flux on there. But it's a double-sided board as well, so I've got to try and get the flow through to the other side of the board. And hopefully it all works. I find out we go to power it up. I've got flux running down the board, I'm going to get rid of that before it goes everywhere. It's soldered nicely anyway. It's got some excess solder on here now. I was trying to get it to flow through. Right. So, there it is, right there. So I'll give that a clean up after I've verified it works okay. Let's get this board out and flopping around. And it is sitting there, kind of wonky, but it's in. Yeah, I'll make it a bit less wonky, I suppose. But yeah, right. Let's drop this over, put a screw in, hold it in place, and then I'll power it up and see if it actually works. It should work, and as long as it does, then we're all good. Put one screw in. So channel 2 was the channel which had the issue, so I'll look at that one. Turn this on. So it's interesting, showing a slight negative voltage there. Might be nothing. Right, let's go up on. Channel 1, channel 2. Yep, there we go. 0 volts. That's working. Excellent. So it's just change the levels. I've done a rough calibration on this. I need to go through and do it again. It's slightly out of calibration still, but it's not bad. I was a long way off before, so it's a lot closer now than it was before, but I need to do some more work on it. There we go. So it is working. Right, channel 1. So you can get exactly right levels on both the meter and on display. So channel 2 can do the same thing. I just need to work on that calibration. I did it close. I did it quite roughly. I was just trying to see if I could calibrate it, and you know, I didn't do it precisely. I was just doing a rough calibration. I mean, it's close, but it's just very slightly off. The output voltage look pretty good on that meter until you get to the 8 volt one. But it's just the display's looking slightly off. Maybe I need to do some work on that part. But yeah, all good. So that actually works. I'm happy with that. Almost job done. I might show you calibration. Right, so I'm going to try doing a calibration on this thing. We'll see what we get. I've got my DC lights up here. Nothing calibrated, nothing configured yet. It's just on. I've got this meter here as well for your reference. I'm not going to be using this meter, I'm going to be using my bench meter up here, my 6.5 digit Agilent, which is connected up there. That's why there's all these banana jacks all stacked up. So the first one's going to my, first jack goes to this one, second pair goes to the Agilent, and this third pair is going to the load. Okay, so explain all that. So to get the calibration menu, hold the button down, and need to power the unit up, and you wait. Okay, record that beep. It says unsecured, that's fine. You can get these things that are locked, so you can't actually play with settings. It's obviously a factory thing, you know, where it's like a production line, people playing with them. So you've got cal mode displayed on display there, and you can actually change what thing you're looking at there. So if you don't want to do a full calibration, you don't have to do a full calibration. Okay, in cal mode, it will guide you through the full calibration, both channels. Now channel 1's okay, I'm not worried about that one. Channel 2 needs calibrating. Right, so I don't have to do channel 1. So I have to do channel 1 voltage, over voltage protection, or current calibration. I do want to do channel 2 calibration though. So now that voltage 2 set, we're on channel 2 connections here. Push view. Now this is going to be outputting 0.55 volts. That's what it thinks we should be getting, but this is what we're actually getting, is 0.448. My Agilent is basically agreeing with this. It's saying 0.4489 and it's creeping up very slowly, so obviously it's warming up as well. It does drift slightly, so we need to drop this down a bit. Let's go here. 449 is closer. It's drifting up to 449. It's close. It's almost there now. So it is gradually drifting upwards. So it's now at 449. And now it's come down slightly. So it's like, okay. Coming down slightly again. So I'll go down a fraction. We'll do that. Okay, that's pretty close. Next one. 10 volts. So again 10.6 over here. And we're getting 10.6128 on the Agilent. So we need to adjust that. 6 1. No, I suppose we'd call it 3 really, wouldn't we? Yeah, I just want to give it a chance to stabilise, see what it settles down to. You see it's got a high resolution on the calibration setting that does the actual output voltage settings. It goes an extra digit resolution, which is kind of what you expect. So that one's closer to 612 than 613. So we'll do that. Yeah, it's still settling, so I was going to give it a second. Yeah, 612, that's like where it's going to be. Okay. 18.5, so you see 19.77 there. And on the Agilent we're getting 19.754. Although drifting down to 753, I might just leave it there for a second and let it stabilise. So I don't know if you can see the display on this thing, but it's actually saying 19.755. So in this case, this is actually slightly more accurate than the EV log meter, but it's only last decimal place, so it's not exactly surprising. Yeah, 754 now, it's drifted down to that. And that's saying 752.7, 19.7527, and drifting down still. So I'll just wait a bit longer. I like these things to be precise. I'm just fussy like that. I mean, if I was really worried about it, I'd leave it on for half an hour then do it. But this might time out by then. It's drifting down to 752 certainly. So if you don't get this quite right, then those output readings and what you actually read on the display will not match up, which is what I was getting before in channel 2. I didn't wait very long when I did it before. I just whacked them in, moved on. So this time I'm actually giving it a chance to stabilise first, which might make all the difference. So this one's still drifting down. It's probably going to end up being a 1 actually. Yeah, still going down. So I don't know how exciting a video this is going to be, but this is what you need to do, I think, to get the accuracy, is just give it a chance to stabilise and sort itself out. Because things do change. I mean, it has a voltage reference in there. So I'll probably go through the calibration and then go through it again and verify it and just see what the actual outputs are and see if it matches up or not. It's still drifting down. So I might even go through the voltage calibration a second time before I do anything else and just double check it. but it doesn't actually retain the setting as such. It's like when you load the calibration up, it doesn't use the last calibration to set the next calibration. Yeah, it's going to be 750 at least. So yeah, I mean you can see it's drifted by 4 millivolts. Woohoo, 4 millivolts. But yeah, I'm trying to get this thing accurate. It doesn't really matter that much, but I'll leave it there. I think that's going to be good enough. There you go, calibrating. That does over voltage protection, which is what it's doing right now. And you've got to do currents. Okay, so now I only want this on there. I'm going to change this configuration around, so I want my Agilent multimeter in series with this. Okay, I'll come back after I've reconfigured this. Okay, everything is daisy chained, so it goes, negative goes to the load, which then comes out of the load to this meter, which then goes to the Agilent meter, which then comes back to the power supply. Right, so all those meters are in series. So that means I should be able to measure the actual current on each of these meters as well. Obviously the Agilent's going to be high resolution. I've got 7 digits showing right now, so yeah. This is for your reference really. I'm not actually using this as a proper reference. I mean it's okay, but it's I want a high precision in this case. So the current calibration, let's do it. So I should be doing 200 milliamps. The power supply should be limiting, not the load. I'll go to 0.5 amps instead. Oh, can't set 0.5. Oh, it's that wrong around. Do half an amp on here, right? That should give us a big enough window on there. Right, let's turn the load on and see what happens, shall we? So it says 200. We're getting 200 in there. The Agilent says 201. Right, and the load says 200.2. So yeah, they're all fairly close, but so 201.2 is pretty close. We're just watching the drifting, see what it's doing. It's pretty much there. It's yeah, it's as close as I'm going to get that. That's fine. So next thing, 1.5 amps. Okay, so let's increase this to 1. Let's just go 2 amps. Right, oh, current set 2 amps. All right, so it's 1.6 on there. You see 1.6 on here. My Agilent is saying 1.6139. So let's adjust this based on the Agilent, because that's the one I trust the most out of all these. I mean this is close. I mean it's the last significant digit. I mean they're all really close. So 1.613958. 7. It's bouncing around a little bit. That's really close there. If I do 39, oh, that's wrong. Oh, I'll come back and do that one in a second. I'll do it again. Damn it. Okay, it's 2.8 amps. So I want to do current set 4 amps. Alright, so it's 3 amps on there, 3 amps on there, 3 amps on here. It's supposed to be 2.8 ish. So anyway, we'll go 3.027 or 69. It's almost 7 really. Yeah, it's 7 now. It's bouncing up to 7. So we'll do that one. Alright. Let's turn the load back off. Hope it's already off anyway. Alright, so I just want to do the current again because I didn't quite get the resolution I wanted on a second stage. So I'll do it again. Current 2, cal, yep, so 200 milliamps. Turn the load on. 200 in there. 202, 201, so I'll do that again. Yep, 1.2, yep, done. Next one, 1.5. I didn't get the resolution I wanted on this particular scale, so let's do that one again there. It's kind of 4 really. Varies very slightly. One, two. Closer to 2, I think. Right. Done. Load off. Okay, so that's that. Right. So that should be that done. So what we'll do now is make sure these are all reconfigured to be voltage again. This is okay, but yeah, unplug this one, unplug that one. Switch all the meters back to voltage, change probe leads. Don't want to blow anything up. And we'll see what we get as far as accuracy from those. Volts, output on, channel 2, 1 volt. It's not bad. 2 volts. I just want this display to be accurate. Yeah, that's looking good so far. Oh, it's gone slightly higher there. So display isn't bang on. That's 8 volts there. So it's measuring, you know, it's just displaying slightly high there. That one actually kind of agrees with it, but my Agilent is saying no, it's not quite right. But I can probably tweak that in calibration, but it's saying it's already slightly better. Got a high range. Yeah, it's just reading a fraction out there. I might have to look at the calibration again. I might have to just run it under average it rather than over average it. I don't know, but I tend to round up, so that's what's going on here. I need to round down. Maybe I should be rounding down. But yeah, okay. So let's check channel 1. So that one stays rock solid. And that's reading a fraction under. So maybe that's what I need to be doing is rounding it down in order to get that correct. This one's reading a fraction down. But that's actually pretty much right though. It's not bad. I mean, I don't. Maybe I'm being too fussy about it, but yeah, it works. So it's better than it was. Certainly much less error than it had before. And yeah, I reckon that's pretty good. So it works properly. I'm happy with that. Should I current test the power supply? I think I should do that. I can current test channel 1. I didn't actually check these to see what they look like, did I? So let's just do 1 amp. Oh, I always do it the wrong way around. 1 amp. Turn it on. Channel 1, that's why I'm not seeing it. Okay. So current set 2 amps. Oh. Current set 2 amps. You can see I don't use this that often, do you? There you go. 1.5 amps. Because I'm in high range. Low range. Alright. Turn the low back off. Which range am I on? Still in high range? No, I'm on low range. So I should be able to do in low range 3 amps on a channel. Alright. Current limiting set at 1.5 amps. Alright, turn it back on. There we go, now we're getting 2 amps. Alright, let's do current set 3 amps. And yep, 3 amps. So I can do it. Let's do the same thing for channel 2. Not 8 volts, max it out. Okay, turn it on, 1 amp. Yep, that's working. 2 amps. Limited to 1.5. Is that because I I've still got that bloody limiting on here, haven't I? There we go. Right. So it's doing 2 amps, 3 amps. There we go, 3 amps. You can do it. All good. So both rails are working okay. Both produce the power. So I'm happy with it. Let's try the high range, and we'll change the voltage to maximum voltage. This should only do 1.5 amps at this thing. So yeah, that's where we go. Dropping out 1.5 amps. Yep. I'll do the same thing for channel 1, which is why that current limiting set, which is a bit of a pain actually, having it automatically change itself. But no, that's what it does. Oh, that one. High range. Come on. 20 volts, max it out, 1.5 amps, yep, all good. So that's working fine. Job done, it's fixed.